This is SpaceTime Series 27, Episode 53, for broadcast on the 1st of May 2024. Coming up on SpaceTime, a new hypothesis to explain the Martian methane mystery, a spectacular jagged mountain and lava lakes discovered on the volcanic moon Io, and trouble as NASA's planet-hunting satellite TESS suddenly shuts down. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A new study may help explain why scientists are continuing to detect methane in the atmosphere of the red planet Mars. Martian methane readings have been detected for years by both spacecraft orbiting the red planet and by Earth-based telescopes. And follow-up ground observations by NASA's Mars Curiosity rover then confirmed the readings during its exploration of Gale Crater. While methane can be produced by chemical processes such as geological reactions involving water and rocks deep underground, it's most commonly produced here on Earth through biological processes by bacteria or flatulent cattle. Now, scientists are yet to spot any Martian cows. So the ongoing detection of methane on the red planet has researchers scratching their heads. The Martian methane also appears to be happening seasonally, usually only when it gets warm. Now, all that bodes well for a possible biological cause. But before you get too excited, when it gets warm on Mars, frozen permafrost often turns liquid, and so water and rocks could still be the answer. And remember, scientists still haven't found any convincing signs of either current or past life on Mars. Yet Curiosity has continually sniffed out traces of methane gas near the surface. However, the car-sized six-wheeled rover has found that the methane it's spotted is behaving in unexpected ways in Gale Crater. For example, it appears at night and then disappears during the day. And it fluctuates seasonally, sometimes spiking to levels 40 times higher than usual. And surprisingly, methane isn't accumulating in the atmosphere. For example, the European Space Agency's ExoMars Trace Gas Orbiter, which was sent to Mars specifically to study gas in the atmosphere, has not detected any methane. So, why do some scientific instruments detect methane in the red planet's atmosphere while others don't? Well, now a report in the Journal of Geophysical Research Planets may have an answer, or at least part of one. It suggests that the methane, no matter how it's produced, could be sealed under solidified salt that might form part of the Martian regolith, that is, the red planet's soil, made up of broken rock and dust. When temperatures rise, either at specific times of the day or during warmer seasons, the seal weakens and the methane seeps out. The study's lead author, Alexander Pavlov from NASA's Goddard Space Flight Center in Greenbelt, Maryland, says his computer modeling suggested the gas can also erupt in puffs when the seal cracks under the pressure of, well, say a rover the size of Curiosity driving over it. The hypothesis may help explain why methane's only been detected in Gale Crater, given that it's one of two places on Mars where a robot is roving at the moment and where it's drilling down through the surface. The other is Jezero Crater, where NASA's Perseverance rover is at work, but it doesn't have a specialized methane detecting instrument on board. Interestingly, Pavlov traces the origins of his hypothesis to an unrelated experiment he led back in 2017. That involved growing microorganisms in a simulated Martian permafrost infused with salt, much like the Martian permafrost really is. Pavlov and colleagues tested whether bacteria known as halophiles, which live in saltwater lakes and other salt-rich environments here on Earth, could thrive in similar conditions on Mars. The micro-growing results proved inconclusive. But the researchers noticed something unexpected. The top layer of soil tended to form a crust as salty ice sublimated, that is, turned straight from a solid into a gas, leaving the salt behind. Pavlov says he remembered the soil crust observations when Curiosity detected a methane burst that no one could explain. And that's when he and his team began testing the conditions that could form and crack hardened salt seals. So, the authors tested 5 samples of permafrost. These were infused with varying concentrations of a salt called perchlorate, which is widespread on the red planet. Now, there's likely no permafrost in Gull Crater today, but the seals could have formed long, long ago when Gull Crater was both colder and icier. The authors exposed each sample to different temperatures and air pressures inside a Mars simulation chamber. Periodically, Pavlov's team injected neon, a methane analogue, underneath the soil sample and measured the gas pressure below and above it. Higher pressure beneath the sample implied the gas was trapped. Ultimately, a seal formed under Mars-like conditions within 3 to 13 days, only in samples with between 5 and 10% perchlorate concentration. Now, it's worth pointing out that's much higher than the salt concentration levels Curiosity's actually measured in Gull Crater. But the regolith there is rich in a different type of salt mineral called sulfates, which Pavlov's team now want to test next to see if they can also form seals. This report from NASA TV.
We want to know, has life ever existed on Mars? Do pockets of life persist on Mars today? NASA's approach to answering these questions is to break them down into smaller and smaller steps. First, we need to know if ancient Mars was habitable. Did it once have the right climate and the right chemistry to support life? The Curiosity rover is investigating these questions by looking for organic molecules containing carbon. Organic molecules are the backbone of all life on Earth, though they can also come from non-living sources. Today, the surface of Mars readily destroys organics, making them difficult to detect. Curiosity landed in Gale Crater on an ancient lake bed. A few months after arrival, it drilled into sedimentary rocks and detected traces of organic molecules using an instrument called SAM. Now Curiosity is climbing the mound in the middle of Gale Crater, and SAM has made a subsequent detection of organics. This new detection is exciting because it comes from rocks that are billions of years old. That means that the organic material within them is extremely ancient. Some of the organics that SAM has detected contain sulfur, likely introduced through geological processes. Sulfur can act as a preservative, binding organic molecules together to make them tougher and protecting them from oxidation. In fact, sulfur is the element that makes hair and fingernails tough, as well as vulcanized rubber. Martian sulfur has probably had a similar effect on these old organic molecules, helping to preserve them over geological timescales. SAM made the new detections by heating samples of crushed rock to very high temperatures, above 1,000 degrees Fahrenheit. This vaporized the samples and released several species of small hydrocarbons like benzene and propane. Because the hydrocarbons were released at such high temperatures, they may be the fragments of bigger, heavier molecules within the rock similar to kerogens. On Earth, kerogens are found in rocks like black shale and coal and are the products of ancient plant and bacteria. We don't know if the organics on Mars are of biological origin, but it's exciting to find such old material preserved right at the surface. This finding is also encouraging for future exploration. NASA and the European Space Agency are preparing to send the next generation of rovers to Mars, carrying new technologies to search for signs of microbial life. In the distant past, Mars was much warmer and wetter than it is today. The rocks at Gale Crater tell us it was once an environment where life as we know it could have survived. The discovery of ancient organic molecules shows that another ingredient of life was present at that time, and it broadens our understanding of habitability of both ancient and modern Mars.
This is Space Time. Still to come, spectacular jagged mountains and lava lakes discovered on the volcanic moon Io, and NASA's planet-hunting test satellite suddenly shuts down. All that and more still to come on Space Time. Data collected by NASA's Juno spacecraft during 2 recent flybys of the volcanic Jovian moon Io has highlighted some of this violent world's most dramatic features, including a spectacular jagged mountain spire and an almost glass-smooth lake of cooling lava. The new findings were announced at the European Geophysical Union's General Assembly in Vienna by Scott Bolton, Juno's principal investigator from the Southwest Research Institute in San Antonio, Texas. Juno made extremely close flybys of Io in December 2023 and February this year. in both cases getting to within about 1,500 kilometres of the Moon's surface. Juno's most recent flyby of Io on April 9th only came within 16,500 kilometres of its surface. But it did allow the spacecraft to obtain the first close-up images of Io's northern latitudes. Bolton says Io is simply littered with volcanoes, some of which were spotted erupting. Juno also studied a 200-kilometre-long lava lake called Loki Patera. The lake has strange islands embedded in the middle of a potential magma lake rimmed with hot lava. The observations recorded by Juno suggest that parts of Io's surface are as smooth as glass. In fact, they're very reminiscent of volcanically created obsidian glass here on Earth. Maps generated with data collected by Juno's microwave radiometer instrument reveal Io not only has a surface that's relatively smooth and flat compared to Jupiter's other Galilean moons, but it also has poles that are much colder than its middle latitudes. During Juno's extended mission, the spacecraft flies closer to the North Pole of Jupiter with each pass. And this changing orientation has allowed Juno to improve its resolution of Jupiter's northern polar cyclones. The data allows multi-wavelength comparisons of the poles, revealing that not all polar cyclones are created equal. Juno's project scientist Steve Levin from NASA's Jet Propulsion Laboratory in Pasadena, California, says that perhaps the most striking example of this disparity can be found in the central cyclone at Jupiter's North Pole. It's clearly visible in both infrared and visible light images, but its microwave signature is nowhere near as strong as other nearby storms. And this tells scientists that its subsurface structure must be very different from these other cyclones. The Juno team continued to collect more and better microwave data with every orbit, and they're expecting to develop very detailed three-dimensional maps of these intriguing polar storms. One of the mission's primary science goals is to collect data that could help scientists better understand Jupiter's water abundance. Now, to do this, the Juno scientists aren't looking for water itself. Instead, they're looking to quantify the presence of hydrogen and oxygen, the two molecules which make up water in Jupiter's atmosphere. An accurate estimate's critical for piecing together the puzzle of our solar system's formation. See, Jupiter was likely the first planet to form out of the protoplanetary disk 4.6 billion years ago. And it also contains most of the gas and dust that wasn't incorporated into the Sun. Finding water abundance in Jupiter also has important implications for the gas giant's meteorology, including how wind currents flow on Jupiter and its internal structure. Back in 1995, NASA's Galileo probe provided the earliest data set on Jupiter's water abundance. That happened during the spacecraft's 57-minute suicidal descent into the Jovian atmosphere. It's one of the stories we covered on one of our very first episodes of Star Stuff, the precursor to SpaceTime, on ABC News Radio. The data collected by Galileo, however, created more questions than answers, indicating the gas giant's atmosphere was unexpectedly hot and, contrary to what computer models had predicted, bereft of water. Galileo did amazing science, but its data was so far afield from existing models of Jupiter's water abundance that scientists considered whether or not the location it sampled could simply be an outlier. Now, new data from the Juno probe shows that the long-sought-after water abundance is actually nearer Jupiter's equator. That's roughly 3 to 4 times the solar abundance when compared to hydrogen. So this definitively demonstrates that the Galileo probe's entry site was an anomalously dry, desert-like region. The results support the belief that during the formation of our solar system, water ice material may have been the source of the heavy element enrichment, chemical elements heavier than hydrogen and helium, that were accreted by Jupiter during the gas giant's formation and evolution. The formation of Jupiter remains puzzling because Juno results on the core of this king of planets suggest a very low water abundance there, a mystery that scientists are still trying to sort out. Data collected during the remainder of Juno's extended mission may help, both in enabling scientists to compare Jupiter's water abundance near the poles to that in the equatorial region, and by shedding new light on the structure of the planet's dilute core. Juno will execute its 61st flyby of Jupiter on May the 12th. This is SpaceTime. Still to come, NASA's planet-hunting test satellite suddenly shuts down, and later in the science report, discovery of a link between a form of rheumatoid arthritis and gene mutations found in blood cancer. All that and more still to come on SpaceTime. NASA's Transiting Exoplanet Survey satellite TESS has entered safe mode, temporarily suspending science operations. Mission managers say the spacecraft itself remains stable. The incident happened during routine science operations, and it follows a separate safe mode event which took place last month during scheduled engineering activities. Mission managers are now trying to determine whether these two events are connected. During the first shutdown, controllers powered up the spacecraft's instruments again, and following the successful download of previously collected science data stored on the mission's recorder, the probe was returned to normal operations. Launched in 2018, TESS scans the skies, hunting for planets beyond our solar system. This is Space Time. And time now to take another brief look at some of the other stories making news in science this week with a science report. Scientists have discovered a link between a less common form of rheumatoid arthritis and gene mutations found in blood cancer. Researchers were surprised to discover that many patients with mutations in epigenetic genes that can lead to lazy marrow or acute myeloid leukemia also had a form of seronegative arthritis. You can read this story in full in the journal Blood. A University of Adelaide study of shallow water fish communities on rocky reefs in southeastern Australia has found climate change is helping tropical fish species invade temperate Australian waters. A report in the Journal of Animal Ecology claims the fish are travelling the Australian ecosystems as larvae caught in the East Australian current. Now, they'd normally not survive in the cooler Australian ocean waters, but the warming East Australia current keeps the baby fish warm and increases their likelihood of survival. In fact, many subtropical fish species normally restricted to Queensland waters are now being found in Sydney Harbour. And fish normally found in temperate waters are being found further south in Tasmanian waters. But that's leaving Tasmanian coastal fish with nowhere to go. We already know that artificial intelligence chatbots tend to push a distorted woke view of the world. But now scientists are reporting more and more cases in which artificial intelligence are lying. Although they don't use that term, they call it hallucinating. One such story of hallucination, reported in the Journal of the American Medical Association, concerns Google's AI chatbot Baird, which apparently hallucinated, citing a research paper that doesn't exist. Scientists were using Baird to help prepare a presentation, and they asked the chatbot to find references for the information provided. But on double-checking the references it provided, researchers couldn't find any trace of the article titled Telemedicine for the Management of Airway Stenoses and claimed by Baird to have been published in the scientific journal Expert Review of Respiratory Medicine. Baird was then asked to summarize the article, which it did quickly. But as the researchers continued to check up on Baird's work, they were unable to find the article it referred to, despite extensive searches. So they asked Baird, does this paper actually exist? And the chatbot responded, and I'm quoting here, "I apologise for the mistake. I have double-checked, and the paper Telemedicine for the Management of Airway Stenoses by Thomas et al. 2022 does not exist." It then went on to claim that it's still under development and was always learning, and it will try its best to avoid making similar mistakes in the future. Unquote. Intrigued, the authors then turned to another chatbot, this one being Microsoft's Pilot, which also claimed erroneously that it had found the non-existent article and even provided an abstract. That's the short summary at the beginning of a scientific paper. This story highlights the importance of double-checking and even triple-checking anything and everything artificial intelligentsia says. An Ohio-based company has invented the first ever flamethrower-wielding robot dogs. Known as Therminators, these remote-controlled electronic quadrupeds can shoot jets of fire over distances of more than 10 metres. The four-legged metallic monsters are equipped with laser sights and first-person video feeds to navigate environments, as well as light-sensitive mapping capabilities to operate at night. With the details, we're joined by technology editor Alex Zaharov-Reutt from TechAdvice.life.
Well, it looks like a dog that was made by Boston Dynamics. So it's very similar to that robot sort of dog. And you can actually buy the dog by itself from the company Unitree Go that made it. It's about $1,600 US to buy the dog by itself, and with a controller it's about $3,000. But if you buy it from Terminator, they have not only a catchy name that sounds like Terminator, but they have been able to modify it so that it has a flamethrower on it, and it's selling for $9,420 US. It's an arc flamethrower on top, and they're saying that it can be used for perimeter defense, wildfire control and prevention, agricultural management, ecological conservation, although burning things down doesn't sound very conservatory to me, snow and ice removal, and
I think
entertainment.
they call it back burning, don't they?
Well, yes, that would be true.
In this case,
yes.
quite literally, because the flamethrower is on the robotic dog's back.
Well, they're calling it the ultimate firepower companion, and it's the first ever flame-throwing quadruped robot dog. So I've seen some of these dogs in action. They're quite noisy, and they can do little tricks. They can sort of dance and do the shuffle dance sort of thing. You can have them having a bit of fun. I mean, there is a LiDAR mapping capability. There's first-person view navigation. You've got this instant ignition. It's got a 30-foot firing range, remote observation, laser sighting, obstacle avoidance. So there's a bit of AI in there. It's a clever thing.
It's not manufactured by Cyberdyne, is it?
Not to my knowledge,
Okay.
not yet. No, I mean it's
Skynet haven't bought a few.
not that I'm aware of. But look, this company also has flamethrower drone attachments, and they've got other flamethrowers. So clearly they're in the flame business.
Elon Musk was selling flamethrowers for a while too, wasn't he?
He was, yeah. Look, they're legal in 48 US states. They're not actually classified as a firearm. He made 10,000 and they sold out very quickly. I don't think he's making them anymore. But look, this is just a bit of fun. They've gotten a lot of publicity. They announced it halfway through 2023. So it's taken about 9 months, from the announcement to actually being available to purchase. And so it's a bit of fun. People are going to buy it for fun. And, but you have to have basically 10K spare. And so if you do have 10K spare, good luck to you.
That's Alex Zaharov-Reutt from TechAdvice.life. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favorite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more space time, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.